Okay. Oh, we probably need the television today, don't we? Don't we have some graphs?
Yes.
That's crazy.
Crazy. I would say that's insane. Yeah.
All right. Number 12 is x squared over 81 plus y squared over 16 equals 1. Number 14 is y plus 2 quantity squared all over 81 plus x minus 1 quantity squared all over 9 equals 0. 16 is x minus...
Is that supposed to be 0 or
1. X minus 3 squared all over 100 plus y plus 6 quantity squared over 64 equals 1. 18 is y minus 6 quantity squared over 25 plus y plus 1 quantity squared over 9 equals 1. 20 is x minus 3 quantity squared over 25 plus y plus 4 quantity squared over 4 equals 1. 24 is the picture.
Did you just skip 22?
I guess so.
Oh.
22 is x plus 6 quantity squared over 25 plus y minus 2 quantity squared over 4 equals 1. The next few are pictures.
Yippee. Can't wait.
You can wait. You're fine.
Can't wait, but...
No, it doesn't. All right, there is 24. All right. Oh, that's crazy. $26 is right there. $28 is that one. $30 is this one. We went through what? 32. 32 is x squared over 2,786,629.3 plus y squared over 181,584.8 equals 1. What questions do we have on that lesson? 22 and 14. I bet we could do 22 and 14. It was such a fun sound. $14 can be easier. Well, no, I can give us a little sketch. That's fine. 14, we are told that this is at, 4, -2. And we are told that this is -2, -2. We are told that this is 1, -11. And we are told that this is 1, 7. And we are asked to write an equation for the ellipse. Why is there a dot at the 6? Because there's a dot at the 6. Okay. We need to know the center. We need to know A, and we need to know B, correct? Yeah. So, how could we find the center?
Find the one.
Count to the center.
Find the ones that don't change. And then.
Or you could find the ones that don't change, and then that's the center. That's true. So the center would be at 1. Something I did wrong. Yeah, this should be a negative. That don't make no sense. We don't know how to rotate them yet. That's pre-cal. That's where it actually gets hard. Okay, so it is at 1, -2. So H is 1 and K is -2. Easy peasy. So what we know right now as of this moment is x minus 1 squared over, actually, let's write it the other way, yes? Because y is our long one. We'll put the one with a at the beginning first. So y plus 2 over a squared. This is squared plus x minus 1 over b squared equals 1. This is also squared.
Why does it matter if it's y or x first?
It doesn't matter, but the way we wrote our formulas, A goes with the longest, the letter A goes with the longest side. So the y one is the major axis. So it's easier to keep it all straight if we do it that way. All right, so we got to figure out A and B. So we need some formula-like artifacts that have A and B in them, right? A is the one that goes with Y in this case, right? Because it's the long one. So how do we find the vertices? What is the formula for vertices? H. And then K plus or minus A.
I said B, but that was wrong.
Right?
That's for co-vertices and H instead.
Right. Our vertices are at 1, 7 and 1, -11, right? So K plus or minus A equals 7 and -11, right? We know K is -2. So -2 plus and minus A is 7 and -11. Now, we can think about it that way, kind of algebraically. We can also just think about it with a picture. And even if you're doing this and you're doing it from some other information and trying to get there without a picture, you can still grab you a little tiny sketch and think about it that way. A is the distance between here and here, right? Which is the same as the distance between here and here. So what is this? What is this distance right here? What? 8. That's what she's saying. Is that right? What is this height? -2. -2 up to 7 is 9.
So 1 off.
-2 down to -11 is also 9. So negative 2 plus 9 is 7. Negative 2 minus 9 is negative 11. So A is 9. So A squared is what? 81. We do the same thing with B, right? B is the distance between here and there. So what is this distance, which is the same as this distance? You get from 1 to 4, it's 3. To get from 1 to negative 2, it's also 3, right? So B is 3. What's 3 squared? 9. We did it. Look, Mom.
So
All right. What was the other one that we were doing? Okay.
30.
We did.
Oh,
I did. I don't know what you were doing over there, but you didn't have the dry erase powers. Didn't switch over to the YouTube screen to make sure this is going through. Looks like it is. But we should double check because people will be like, it stopped halfway through. I'm so lost.
Because that's exactly what they say.
According to Bree, at least, the 2 other videos that she watched on some of these topics, of course, I think it was probably on rotations, but still, well, actually, I don't know whether it was. It may have been just on ellipses. Those videos were terrible and confusing, so who knows? So hopefully this is useful.
can we do 30? Actually, no, I think I just.
All right, any other questions on this lesson?
30.
30. Sounds great, let's do it. $30, 7x squared plus y squared minus 56x plus 6y plus 93 equals 0. We're supposed to find the coordinates of the center and the foci and the lengths of the major and minor axes for the ellipse with that equation, then graph the ellipse. So, what do we need to do?
Put it in the right column.
True. Step 1 in doing that is what?
Subtract 93 and sort out all this stuff.
Subtract 93 and then group the x's and the y's. Sounds like a great idea.
Yep.
So, 7x squared minus 56x plus y squared plus 6y equals negative 93. Then what?
To complete this, well, factor out the 7.
We got to factor out a 7 in the first 2. That's true. So we got x squared minus 8x
Now, complete the square.
Now we complete the square. Negative 8 divided by 2 squared. Negative 4 squared. 16.
Plus 16.
So we add 16 and then we add 16 times 7, right?
112. Yeah, 112.
That's great. I didn't ask.
Oh.
I have and will always in this class write it that way because see, now everybody knows and or if they have a question about where it goes, where it comes from. I promise I know what I'm doing. I do get confused sometimes, but I promise I know what I'm doing. Okay. 6 divided by 2 squared. 3 squared, which is 9. So now we add 9 to this side and add 9 to the other side as well. Now what happens? Yeah, you factor it. What is this first one going to factor into? X minus 4, quantity squared, plus y plus 3, quantity squared, equals, so negative 93 plus 16 times 7 plus 9 is some number.
28.
28. I figured it was going to be a multiple of 7. That was going to be my guess.
Yep.
And I was right.
You're so smart.
Just experienced. They don't always equal the same thing. Now what do we need to do?
Divide both sides by 28.
Divide both sides by 28 because we want this to be a 1, right? What happens with the 7 and the 28?
They poof out into a 4.
They poof out into a 4 in the denominator, right?
Not in the numerator.
So, we are asked several things, and we are ready to start answering the several things. All right, we are asked to find the coordinates of the center. So let's start with the easy one. Where is the center?
4, negative 3.
Is it 4, negative 3? That's true. Because it's at h and k, right? Remember, flip the signs to come back over here because it's minus h and minus k in the formula. Right? We are also asked to find the foci. So how do we find the foci?
You need to know C.
We do need to know C. What's the formula for C?
The square root, yeah.
Minus b squared. So we need to know what is A. What is A?
The square root of 28.
It is. Now, we wrote this in this form, but what I was saying earlier is let's put the one with the bigger one first, right? So we can remember what is A and what is B, right? Because it matters. Right?
The bigger one will always be A.
The bigger one will always be A. So it's the square root of whatever's here, right? So it's the square root of 28. Which, in case we need to know, would be the square root of 4 times the square root of 7, which is 2 times the square root of 7, which is approximately equal to something else, which we may want to deal with later. We'll decide whenever we use it. Okay. We also need to know what B is. Not H. So what would B be?
Square root of 4.
Square root of 4, which is 2.
What? No.
Okay. So now we're going to shove A and B into the C formula because we need C in order to find the foci. I'm pretty sure it's pronounced foci, but I could be lying. I don't know.
It's focus. Foci would make sense.
That's true enough.
Are you trying to get a decimal equivalent for A?
We're going to get an exact number for C because this is the square root of 28 squared minus 2 squared. What is the square root of 28 squared?
28.
28. And 2 squared is 4, right?
Yep.
28 minus 4 is
24.
24. So we're not going to quite get an exact number, right? Let's go ahead and grab a decimal equivalent for these, for this one, because we're going to add it to some numbers and possibly graph it and label it.
Square root of 6.
4.9.
Yeah, 4.9. Yay.
Now, how do we find the foci?
Yeah.
Yeah, it's not doesn't actually answer my question.
Plus or minus C minus, or and K.
What direction is this ellipse?
Up,
It's up and down,
down. Yeah.
right? So which direction is changing for the foci? Is it the y direction or the x direction? The y direction. So it's the k one that you're going to change, right? So h and then k plus or minus c. Are you giving up on me? No. You have a give up face today. Are you just a zoned out face? Okay, looks like a give up face to me. Okay. H, we already know, is 4. What is 4 plus 5? No, lies. K is negative 3. What is negative 3 plus 5? 2. And then what is negative 3 minus 5? Negative 8. I didn't think that was a hard question, but sometimes I get confused. Okay, next thing.
Vertices.
The lengths of the major and the minor axis. So, vertices, right?
Does it not ask for the vertices?
It asks for the lengths of the major and the minor axis, which we need the vertices and the co-vertices to have that, right? All right, so the vertices. Length of major axis. Loma. It was also going to be loma, but low. The little n.
What are you saying?
I don't know. It's a tough crowd today. I'm trying my best.
I'm just tired.
Okay. So how do we find the vertices? Are the vertices on the long axis or the short axis? Long axis. So which one's changing, the x or the y?
K. The Y.
The y one, which is with k, yeah? So one of the vertices is at 4 something, right? 4 what? How do we get to the vertices? What are we adding and subtracting?
K plus or minus A.
K plus or minus a. So now we probably want a decimal equivalent for the square root of 28, right? So what's decimal equivalent for square root of 28? 5.3. That's annoying.
Yeah.
What are we even doing? Negative 3 minus 4.9, negative. Because I can't do plus or minus 5 on both of them. We need a little more granularity, right? This was negative 3 plus 4.9, negative 3 minus 4.9 is negative 7.9. Great. Okay, back to where we were. 5.3. So, negative 3 plus 5.3 is what? Yeah, it is. And negative 3 minus 5.3 is what? So the length of the major axis is what?
About 10.6.
10.6. About 10.6.
That's just the difference between 2.3 and negative.
The covertices. Which one's changing, the x or the y? The x this time, right? It's x, it's h, because that goes with x, plus or minus what?
2.
2, because 2 is b. So what is 4 plus 2?
Yeah.
6. What is 4 minus 2? 2. So the length of the minor axis is what? 4. Then graph the ellipse. Great, let's do it. The center is at 4, negative 3. The vertices are at 4, 2.3. 2, 3, 4. No, 1, 2, 3, 4. 1, 2.3. So here ish. And 4, negative 8.3. 1, 2, 3, 4, 5, 6, 7, 8.3. Right about there. Covertices are at 6, negative 3, and at 2, negative 3. And then we connect the dots in roughly elliptical fashion. Let's talk about hyperbolas, which are an ellipse that's been turned inside out. Yeah, that's a scoot. I don't think we need that anymore, though. Oh, I forgot to turn the camera. That's fine. If you're one of my students watching this video at some point and you want to see the answers, message me and I'll send you a picture of the graph ones.
But what if they don't have your number?
Let's see. Yeah, my files. I'm glad that this has helped you. So are these people.
Yeah. How does the... Never mind.
I'm talking to no one though, because nobody's even there anymore. Okay, that's fine. Maybe they'll rewatch it. Could be true.
Wait a second. This isn't pre-calculus.
Everything in this unit is in the same unit in pre-calculus, except the only thing you are missing, the only thing you're missing is the hardest part, and that's taking these shapes and rotating them. Because then you gotta convert stuff, the x prime, y prime axis, and you gotta shove a bunch of trig crap in there, and it's all giant and a mess. They get tested over that today. You guys have a couple days before test. Y'all's is also going to end up perfect, just like geometry. That's the word I'm looking for. All right, so a hyperbola. Here's the standard form of an equation for the hyperbola. So a hyperbola, what is a hyperbola? It is of this shape. Or this shape. Or you can think of it as two parabolas with a couple asymptotes. Either way you think about it, that's what it looks like.
But how does it turn inside out?
Turns inside out and then keeps on going. Right. So everything a ellipse has, a hyperbola has. So for the vertical one, so the one like this, the standard form is y minus k, quantity squared, over a squared. Should be familiar so far, with one major difference. Minus x minus h quantity squared over b squared equals 1.
That is a big difference.
It is an important difference. It is a key difference. A horizontal one, so one that looks like this, is, as you might expect, x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. The foci of the horizontal one, what is going to, if it's horizontal, and the foci, where are the foci going to be on this guy? They're going to be right there and right there, right? So on the horizontal one, what is going to stay the same, the h or the k? The y one, which is the k, right? This is, right? So the k is going to stay the same, but the h is going to be different. So how are we going to get to the h's, do you think?
Subtract a? Or
No, the foci we didn't get with a. That's not how we get to the foci. That's not right.
oh,
Plus or minus c. And then k is going to stay the same. Now for a vertical one, what's going to stay the same on the vertical one? The h is going to stay the same, right? Because the x is going to stay the same. So the h is just going to be h. And the k is going to be plus or minus c, right? Okay. Next are the vertices. What the?
what was that? What did you see?
I was trying to understand why. No, we're not doing that. That's stupid. But vertices, yes, we do vertices.
What was it? What?
But we're not going to worry about co-vertices on hyperbolas because that's stupid. Because no, we're not doing that. That's dumb. The vertices. On the horizontal one, what's going to stay the same?
The y.
The y part, so the k, right? Yeah. And how do you think we're going to find the vertices for the h part?
Plus or minus a?
Plus or minus a.
So it's basically the same thing.
It is.
Subtraction. Okay.
So to find the vertices on the vertical one, what are we going to do? or minus a. Now there is, we're not doing covertices on a hyperbola because that's stupid. We don't need extra random useless points. But we are going to learn the equation of the asymptotes. Because there is an asymptote that lives right here and right here. Same thing for this one. And we're going to write these equations in point slope form because that's going to be easy peasy. Because the point on the point slope form is going to be the center of where those lines cross. So that's handy dandy mandy. Right? So to find the equation of this asymptote, it is y minus k equals plus or minus, right? Because you got two lines. Yes. A over b. Oh, wait. I'm looking at the wrong side. I wrote this backwards. I was right to begin with. Sorry. My brain was right. I read wrong. B over A. This is for horizontal. Times x minus h. Let me get this down, write it down correctly, and then we'll talk about what's happening. How does point slope go? Y'all remember that from a long time ago?
No.
It's y minus y1 equals m times x minus x1, right? x1, y1 is a point on the line, right? Some point on the line, right? We're using specifically this point, right? Because that's an easy one for us to find based on the equation. What is the m? It's the slope, right? The m is the slope, right? Slope is what? What's the two words we use for slope? Rise over run. So it's the one that goes with the y over the one that goes with the x. Rise over run. So that's why it's b over a on this one. This one is exactly the same except it's a over b, right? Because a is underneath the y over here, right? So this one is y minus k equals plus or minus a over b times x minus h, right? Same. Package scheduled for delivery today. That's great. Okay.
Is it?
Are we ready for an example? Okay.
Yes.
Let's do two examples. Let's do let's do three examples. Starting uber easy and going from there. All right. We are going to graph y minus 4 quantity squared over 9 minus x plus 3 quantity squared over 25 equals 1. Now, with a hyperbola, it's a little bit trickier to figure out. It's not any trickier. You just have to remember a different thing. And it's harder to guess your way into what's going on, right? So if this was an ellipse, we'd look like this and go, oh, this is vertical because it's the 25 is underneath the x, right? Horizontal because this would be over here, right? Yep. But you can't just flip it to the big one and be like, oh, it's that way, because the minus would change. So we have to look at which one is coming first, the y or the x. So if we look at this and we compare to our standard forms, Which one is this? Is this the horizontal or the vertical one? Vertical. It's whatever one comes first, it's that, right? Y is vertical. This one's vertical. So this parabola is going to, it's not a parabola. This hyperbola is going to be one that looks like this, right? Easy peasy so far. Right? So this is A and this is B, even though A is smaller on this guy because it's a hyperbola, right? So how would we find A? What do we do to get to A? Square root that. Square root of 9 is 3. How do we get to B? Square root of that, so it's 5, right? What is H? It is -3, right? The H always goes with the X. K always goes with the Y, right? And then the K would be 4. It's always the opposite sign, right, of what's in the inside. Always, always. So we have all of the puzzle pieces except for C. Let's grab C. We don't really need it because all it says is graph it, but, oh, just kidding. It also says identify the vertices, foci, and asymptotes. Oh, there's one thing I didn't write in your notes that you need to add to your notes in the equations. Because we find C a little bit different. Only barely. C is the square root of A squared plus B squared. So for the ellipse, it's minus in the middle. It's the opposite of whatever's in the standard form, right? So the ellipse has a plus in the middle and a minus in the C. Hyperbola has a minus in the middle and a plus in the C. Okay, so it's opposite of that. Let's find C real quick. So C would equal the square root of 9 plus 25. So it would equal the square root of 34, which is approximately equal to what? 5.8. Nobody was doubting you in that instant.
You're so smart at doing it.
Thank you. I know.
Wow, that was so affirming of you. All right, so to find the vertices, this is a parabola that opens this way, right? So what is going to stay the same, the H or the K? The H, the one with the X, is going to stay the same, right? So negative, they're both going to be -3 something, right? Easy peasy, right? Then the K is going to be plus or minus whatever one goes with the Y, right? Which is A in this case, yeah? Right? So, 4 plus 3 is what?
7.
4 minus 3 is what? 1. So it's got vertices there and there. I'm going to start building my graph. Got enough to kind of get something to work with. Not enough to get it all, but something to work with. -3, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. And -3, 1. So right here and right here. So it's going to go and right? The center of the asymptotes is at -3, 1, 2, 3, 4, right? We don't know their slope yet, but that's going to be a useful point. We're asked to find the foci, so let's find the foci. We have all the puzzle pieces to find the foci. Which one is going to stay the same? The X again, right? The H, yes? So it's still going to be -3 something. And it's plus or minus C this time. So 4 plus 5.8 is what?
9.
9.8. 4 minus 5.8 is what?
Negative 1.8.
Negative 1.8. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9.8. So here, and negative 3, negative 1.8. So about right there. If you can kind of picture a thing going around, wrapping around that, that's where we're going to end up, right? We're probably asked for asymptotes, right? Even if we weren't asked for them, it's nice to grab them because it helps graph it easy, right? Makes graphing it like super simple. So y minus 3 equals rise over run, right? So the y one over the x one. So 3 over 5 plus or minus times x, what is it? Plus 4, right? So we'll count our asymptotes. Up from the center, 1, 2, 3, over 1, 2, 3, 4, 5. Did I count too many? 1, 2, 3, 4, 5. Yeah, I thought I counted too many. So here, put us a dotted line.
Wait, you're putting in the 3, 5?
I'm counting from the center, so 3, negative 4, so this point right here, and up 1, 2, 3 over 1, 2, 3, 4, 5. We're not counting from the y-intercept, we don't know that, we're counting from here. And then we're counting down 1, 2, 3 over 1, 2, 3, 4, 5. I did something wrong. Oh, I did back. I made a algebra 1 mistake, or pre-algebra mistake. I counted down and back. What am I doing? Went back to middle school for a minute. How about down and then over? 1, 2, 3, 4, 5.
Those points are the same points, or same.
What?
What am I trying to say?
I have no idea.
Yeah, those points are the same y-axis as the vertices. Points that they're the same.
They did. They don't always, but
Always.
no, but in this one they did. In this one they did. I think that's all we're supposed to find. Now we just need to graph it, right? So all we do to graph it is we start at our vertices, right? And then you just kind of head towards the asymptote. So like I say, even if it doesn't ask for the asymptote, it's definitely easier to graph if you pop your asymptotes on there. Because then it's much easier.
Mucho easier.
Change the mind, we're going to do 2 examples instead of 3. Here we go. Actually, time changed it for me. We're going to do this one. Because I think we could use some more practice with this. I'm going to graph it, identify the vertices, foci, and asymptotes. 16x squared minus 9y squared plus 128x plus 36y plus 76 equals 0.
Subtract 76.
Yep, we're gonna do all our completing the square things, right? So I'm gonna group our x's. 16x squared plus 128x minus 9y squared plus 36y equals negative 76. We're going to factor 16 out of the first chunk. X plus 128 divided by 16 is? 8.
Oh my goodness, I guessed that.
That's crazy.
Super.
What are we going to factor out of the next one? Negative 9. There it is. I found it. And I broke it. That's cute. It's a counter. It's a dead counter.
Goodness. How dare you, Sean? Why'd you break it?
Minus 4y equals negative 76. At this point, if we were doing this problem, we weren't told what kind of conic it was, we'd be like, okay, this is going to be a hyperbola because these two numbers are not the same and there's a minus in it. Right? Now we do the green part, right? 8 divided by 2 squared is 4 squared, which is 16. So we're going to add 16, and we're going to add 16 times 16, which we already know. So I'm going to just write 128. No, just kidding. That's not right. It's more than that. It's quite a bit more than that. What did I do? Negative 4 squared. No, I got this. Negative 4 divided by 2 squared is negative 2. Squared is 4. So we're going to add 4 on this side, and we're going to add 4 times negative 9 on this side. Right? Then we're going to factor. So we've got 16 times x plus 4 squared minus 9 times y minus 2 squared equals 256 minus something. No, that's bigger than 256, isn't it? I don't know, whatever it is. Negative 76 plus 16 times 16 plus 4 times negative 9. 144.
I concur.
It's a good example to do. Look at me being accidentally smart. Now what do we do?
Divide by 100.
We got to divide by 144. If we didn't know what kind of conic this was, we'd have to stop and think, okay, is this a circle?
No.
Because if this was a circle, then we don't want that to be a 1. Otherwise, we got to divide that mess off of there. It's not a circle. We know that because these are not the same and minus, right? We already figured that out. 16 over 144 reduces to what? 9. So x plus 4 quantity squared minus, what does 9 over 144 reduce to? We'll put a 9 there where it belongs.
Are we doing 16 divided by 144?
Mm-hmm. Well, you're reducing 16 144ths.
16 is 16.
It's
16.
16 times, oh yeah, duh, obviously, because the other way is the other way. That's obviously true. Y minus 2 squared over 16 equals 1. What is A in this problem?
3.
3. It's the square root of that one, right? Don't forget to do that. What is B in this problem?
4.
4. And H and K, and I'm going to write it as a point this time because I think that's going to be easier for my brain to take a look at it, is going to be at negative 4, 2, right? Which is the center of the asymptotes and the hyperbola.
Wait, H is 2 and K is -4.
That is definitely false.
Yeah, I got that wrong. Oops.
Because H definitely goes with the X.
My bad.
All right, we got to find C, right? So C is the square root of 3 squared plus 4 squared. 3 squared is 9. 4 squared is 16. Equals square root of 25, so it equals 5. Look at that. It's even a whole number. That's nice. That's great. Grand, glorious. Okay. So, the vertices, which direction is this hyperbola going? Is it vertical or horizontal?
Horizontal.
It is horizontal. The x comes first, so it's horizontal. This one's going to look like this, right? So, for the vertices, the foci, what's going to stay the same?
X.
The y is going to stay the same. They're going to be in this line right here, right? The y is going to stay the same. The x is going to change, right? So, one of them is going to be h plus or minus, what are we doing, vertices? Yeah, so the a, right? So negative 4 plus 3 is what?
Negative 1.
Negative 1.
Wait, what one's staying the same?
The y one, because they're all going to be in this line. And then negative 4, no, wait.
Negative 4 minus.
Yeah, no, that's right. That's right. Yeah. Negative 4 minus 4, which is negative.
7.
No, minus. Yeah, that. It is. You have been right all the times.
Except for that time when I mix up the H and K. Like a Google.
The foci, we find the same way, right?
But with C.
But with C. So it's still going to be 2 on the y part. And then negative 4 was C, 5. Negative 4 plus 5 is 1. Negative 4 minus 5 is negative 9. The asymptotes are at y minus 2 equals plus or minus, rise over run. So it's the one that goes with this one over the one that goes with this one, right? So 4 over 3 x plus 4. Let's graph it. So the vertices are at negative 1, 2 here, and negative 7, 2, 2, 3, 4, 5, 6, 7, 2. The equation of the asymptotes is centered at negative 4, 1, 2, 3, 4, and 2, so right here. And we're counting up 4, 1, 2, 3, 4, up 4 over 3, 1, 2, 3. And then we're counting down 4 and over 3. Down 1, 2, 3, 4 over 1, 2, 3. Connecting the dots. Then we're going to grab our vertices and follow it around. Your homework is on page is 628 through 629. You're going to do numbers 10 through 32 evens. Goodbye, kids. We'll see y'all later.
Poor counter. I'll leave it, have stuff with it. We can step out.
You need to build a spreadsheet. You need to build a spreadsheet of all the energy drinks you try.